think I'm live. Let me just check on my phone. Am I live? Am I not live? Let me just check. Am I live? Still not live? Where am I? Hold on. Stop streaming. Am I live? It's saying I'm live, but I can't see anything. Hold on, let me refresh. So why am I not live then? Stop streaming. Hold on. Am I live? It's the right one. I'm just gonna check again. I'm not sure if I'm live. Okay, I think I'm live actually. So I'm just checking. I'm gonna check the chat. I'm just on my phone, guys. I think I'm live. I'm just waiting for the ads. I can see hi, you're live. Okay, cool, 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 cool. All right. And the connection's okay? Let me just see. Okay, I'm live, I'm live, I'm live, I'm live, I'm live. All right. All right, cool. Good evening, guys. I hope you guys are doing well. How are you guys feeling for tomorrow? Guys, confident? I know you guys are gonna smash the exams or the paper tomorrow anyway. But yeah, what we're gonna do today is I've just picked out a couple of questions, and I've actually picked out one more. I was gonna do four, but I thought this would be good to start with as well. So hopefully it's an hour long. It may be a bit longer, but obviously if you need to leave, then you need to leave. That's absolutely fine. But yeah, so I've just picked out a couple of topics, couple of questions that I think may come up. I'm basing it on the Edexcel exam board. So yeah, but obviously it's applicable to all examples, isn't it? Because it's just maths is maths, right? So you got this one here, and let's read it. It says, a company decides to manufacture a soft drinks can with a capacity of 500 milliliters, right? The company models the can in the shape of a right circular cylinder with radius r and height h centimeters. In the model, they assume that the can is made from a metal of negligible thickness. Prove that the total surface area s centimeters squared of the can is given by this formula here. S is equal to 2 pi r squared plus 1000 over r. So I'm just checking. Let me just see the chat just to make sure we're all good still. Okay, cool, cool, cool. All right. So this one, now this can come up. This is just differentiation, modeling and differentiation, right? So I've got a cylinder. So what I'd like to do is I like to visualize these questions. So I'm going to draw a cylinder. So I'm going to get a circle like this, and then let me just make that a bit thicker, just so it's a bit nicer here, like that. And then going to do that there. I'm going to draw another one underneath, like that. And then obviously it's going to be a cylinder, so I'm going to connect these like this. Whoops, no, I need to do that. Put this here. All right, now I'm going to connect these lines like that. And I'll connect the other one like that. All right, so we've got a cylinder here. I will need to prove that the total surface area is equal to that here. So firstly, we're dealing with a surface area. How many surfaces do we have? We've got this one here. That's a circle. That's going to be pi r squared. That's fine. I've got the exact same one on the bottom as well, another pi r squared here. And then this surface around the cylinder, right? Well, what is the formula for it? You can actually memorize it, right? But what I like to do, or to be fair, just memorize it. I think as well, I'll try and find some formula sheet that I have that has all of the formulas that you need to memorize. So for example, cones, spheres, cylinders, so on and so forth, right? But this one here, what I like to do is I've got this one I'm trying to figure out, right? This one in the middle. And then imagine this is like a sheet of paper rolled up, right? If I was to roll it out, what would happen? Well, it's gonna look like this. It's gonna look like a rectangle, like that. And then what will the dimensions of that rectangle be? Remember, I'm trying to model this one here, right? Well, remember this is gonna be the height h, by the way. And what will happen is that, well, this is gonna be the height h, and then what will this distance be here? It's gonna be this part around. No, it's gonna be this part around like that. And that's just the circumference, which is just 2 pi r. So we could just say that the dimensions of this is going to be 2 pi r. So the area is just going to be 2 pi r h, isn't it? So if you want to work out the surface area of a cylinder, it's just going to be equal to the two circles. Whoops. Two circles, 2 pi r squared plus the 2 pi r h. So what we need to do is just obviously figure out, if I compare what we've got to the formula, 1000 over r, we need to get rid of that h, right? So it's the same thing with these types of questions, right? I've got this here. This is my answer. This is the answer, right? Now, because if I compare this to my show that, and that's what you should always do, by the way, always compare your show that with what they've given you, right? Put this here. This is the show that, and this is what we've got here. You want to just essentially say, well, fine, I've got 2 power squared, that's fine. I need to do something with that there. There's a h that I don't want. So let's go back to the question. Question says, what does it tell us? It tells us that the drink has a capacity of 500 milliliters, right? That's the volume, no? That's the volume. And what we can say from that, well, the volume of a cylinder is just going to be the face times the height, right? So it's just going to be, or the cross section, I should say, times the height, which is going to be pi r squared h. And this is equal to 500. So what we can do here is say that fine, we've actually got an equation in terms of h, right? We can rearrange it to make h the subject, and we can plug it back in into the formula. So I'm going to do this here. And by the way, because they've used S, what I'll do actually, I'm gonna move this here. I'm gonna move this here, right? And I'm gonna call it S instead of SA because they're calling it S. So I've got this here, and then this is gonna be S, and then it's gonna be we now know just from that formula there, pi r squared h is equal to 500. So that's the volume. I'm gonna write volume here, pi r squared h, and we know that this is equal to 500. So that means I can just rearrange to get h, which is going to be h is equal to 500 over pi r squared. So now I've got that. That tells me that I need to put this h into that one there. And so that means that I'm going to get s is equal to 2 pi r squared plus 2 pi r. And then instead of writing h, I'm going to write what it's equal to, which is 500 over pi r squared. And then now you can see that we've got an equation for s all in terms of r, which is what we want according to the show then. So now what's left to do is just tidy up, right? So tidying up, we're going to have s is equal to 2 pi r squared plus, and then what happens here? Well, that pi is going to cancel with that pi. That r is going to cancel with one of those r's, and then I've got 2 times 500. So I've got 1,000 here on the top divided by 1r. And that's exactly what they wanted for 4 marks. Does that make sense, guys? We happy with that? I'm just going to check the chat just to see what's going on. Cool. All right. I think this is fine. I'm just looking. Okay, let me go all the way. All right, cool. Yeah. I'm a bit behind, guys. I don't know how to sort out so I can see the chat when you guys are seeing it because I'm way behind for some reason. But anyways, how many? Okay, cool. Good stuff. So we've done that. Let's continue. And then part B says, given that R can vary, find the dimensions of a can that has a minimum surface area. All right, so this question here, a couple of things going on. R can vary, that means R is a variable, which makes sense because we've got the surface area in terms of R. Find the dimensions of the minimum surface area. Well, we're dealing with a can here. So when they ask us for the dimensions, right, they're asking us to figure out what the radius is and what the height is essentially. So what we need to do for part B, we need to find R and H, right? Given that the surface area is at its minimum. Yeah. So again, you can see the word minimum here. When you see that word minimum, maximum, stationary, turning point, right? These are all synonyms for differentiation, right? It's just where your derivative is equal to 0, right? So all we're going to do for this one, I'm going to copy this. What I'll do is I'll copy this whole question here, like that. And yeah, putting this here, this is going to give me, I've got this formula here for S, right, which we did in the part A. Now we need to differentiate this because I'm looking for a minimum, right? So I'm going to write in code dy dx is equal to 0. I know I'm not dealing with y and x, but it's just obviously what we're normally used to. So I'm just going to write this. So if you see that word minimum, maximum with this type of question, now you just need to differentiate, make it equal to 0. So what I'm going to do, firstly, to differentiate this, I need to write this in the right form. So S is equal to 2 pi r squared and then plus 1,000 r to the minus 1. And then if I'm differentiating, right, remember I'm differentiating s with respect to the variable r. So it's always important to get your derivative right. So it's going to be ds over dr. And then differentiating this is going to be 4 pi r. And then minus 1,000 r to the minus 2, isn't it? Bring that to the front, take 1 away. So we get that. And then now remember, we need to make this equal to 0, don't we? Because we're looking for it where it's at a minimum. Yeah? Now solving this, now whenever you see stuff like this, guys, when you've got like a negative power, when you've got in terms of like a polynomial, right? What you should always do is rewrite this as a fraction. And it's quite clear to see how to solve it. If I write r to the minus 2, it's going to be divided by r squared, and this is equal to 0. And what you should always do if you see stuff like this, right? Always multiply by the denominator to get rid of the fraction. So if I multiply by the denominator, I'm going to get 4 pi r cubed, right? Minus 1,000, right, is equal to 0. And I'm just going to write here, I've multiplied by r squared in each of these here. So hope that makes sense. Let me just check the chat just to see how we're getting on. Hope it's all good. Okay, cool, cool, good stuff. All right, so I think that's all fine. Just looking here. Okay, cool. All right, so I think that's fine. So what I'm gonna do now is just continue. So, doing this, we need to add 100, well, add 1,000 divided by 4 pi. So I'm gonna say r cubed is gonna equal I'm gonna add that 1,000 and I'm gonna divide that 4 pi. And then now to get r, I'm just going to do the cube root of that, aren't I? So r is equal to the cube root of 1,000 over 4 pi. And if I put that into my calculator, that should give me the radius. So I'll put this here. And I think no, it doesn't matter to be fair. But I'm going to just do 1,000 over 4 pi. That gives me 8.9. What's the problem here? I think I've made a mistake somewhere. Let me just check. I didn't get that before. Give me a sec. 1,000 over 4 pi. What have I done here? Oh, I didn't cube root it. My bad. I did square root instead. Apologies. 1,000 over 4 pi, like that. And that will give me syntax error. Whoops, I need a pi. And that gives me 4.301, blah, blah, blah. Right. So I'm just gonna write r is equal to 4.301. And they didn't give us they didn't tell us to put it to any degree of accuracy. So I'm just gonna write r is equal to 4.30, just 4.3. So now I've got the radius, right? Now remember, we need the dimensions. That means we need the radius and the height. Now remember, at the very beginning, or from before actually, for this one, we figured out that the height is just equal to 500 divided by the area of a circle, pi r squared. So we can actually use this formula here to just plug in r to figure out what the height is, like that. So I'll do this here, and doing this here. I'm gonna plug that in. So I'm gonna say h is gonna equal then, h is gonna equal 500 over pi, and then 4.3 blah blah blah. What I would do, by the way, is I would actually put the actual answer in. I wouldn't round until the very end. So I'm gonna just say, well, that's my answer. It's gonna be 500 divided by pi, and then answer squared, like that, and that gives me 8.60 blah blah blah, right? 8.60 blah blah blah. So the answer is going to be, the radius is going to be 4.3, and the height is going to be 8.6, and that will be it. Does that make sense, guys? We happy with that? So let's see. Okay, good stuff. I think it's all okay from what I can see in the chat. So yeah, I'm gonna continue. I'm just reading. Okay, cool. No problem. And as well as that, guys, what they can also ask you is to justify that you have a minimum as well. So that's another thing they can ask you, right? They didn't ask you in this case, but if they ask you to justify you have a minimum or a maximum, what you just need to remember is two things, right? If you're what you're dealing with here is, we've differentiated once to make it equal to 0, right? This is what we call our stationary point, or our stationary value, SP for stationary point, right? Now, at this point, we either have a mixed maximum or a minimum. Obviously, we know it's a minimum in this case because they've told us. But when you're dealing with differentiation, you differentiate once and you make it equal to 0. That's a stationary point. Now, at this point, we don't know whether or not it's a maximum or a minimum, generally speaking. So what you'd want to do now is find the second derivative, and that will determine the nature. So sometimes they can say determine the nature, or in the case of this type of question, context, a contextual question, they can say justify. So what you just need to remember, I'm just going to write here so you guys can make a note of it. If you have your second derivative here, d squared y over dx squared, and obviously you plug in your stationary point, if it's greater than 0, then this is a maximum. Sorry, this is a minimum, sorry. That's a minimum. And if it's the other way around, then it's a maximum. Yeah, that's just something you need to remember. So in this case, what you could do to justify it, right, is you could differentiate again to get your second derivative, and then plug in your value and see what you get. And what you notice is that the answer is going to be greater than 0 because we have a minimum here. So you guys can try this, and if I've got time, I'll do it at the end. But yeah, DSR, DS over DR, you differentiate this again, right? You differentiate this again, see what you get. And yeah, plug in your stationary point. So I'll do it here for you guys to try. If I've got time, I'll do it after. So remember, R was equal to 4.3. You'd figure out what D squared S over DR squared is equal to, and then you would plug in your value of thing. Or to be fair, it's actually quite easy. I'll just do it. It's going to be 4 pi minus, or not a minus, that's going to drop to positive 2. And then we're going to have 1,000 like that, and it's going to be R to the minus 3. And then you'd plug in your value, and as you can see, to be fair, I'll just tidy this up. It's going to be 4 pi plus 2,000 over R cubed. If I plug in 4.3 to that, that's a positive number. This is going to be positive. So it's going to be greater than 0, which justifies it's a minimum. You can just double check yourself. Yeah? But that's just something to be aware of. But yeah, that's it. And in part C, it says, with reference to the shape of a can, suggest a reason why the company may choose not to manufacture a can with a minimum surface area. Now, this one, when I looked at the mark scheme for this one, it referenced something about the radius being too big for our hands. So, yeah, what I'll do actually, I'll just show you what it says. Where's the solutions? I think I've got it here for this one here. So this is what it said here, right? State a valid reason. So the radius is too big for the size of our hands. If R is equal to 4.3 and H is equal to 6, the can is square in profile. And they've just talked about the different dimensions and it being difficult to stack on the shelves. Now, if I'm being honest, I don't really get why this is a reason not to, if I'm being totally honest. But yeah, with these ones, it's only 1 mark. And yeah, just make sure you just write something in context and you should be good. So, done that. Now let's go to the next one. So I'm going to go back to Monday, 3rd of June. We've done that. Now the next one is sequences in series in context. So how do we find this type of question, guys? Put a 0 if sequences in series is easy. So put a 0 if you find it difficult, don't like sequences in series. Or put a 10 if it's super easy, very straightforward. If this comes up tomorrow, you're going to get 100% in this question. I want to see what you guys say. And again, I think it's going to be delayed, to be fair. So what I'll do is I'll just continue because I know it's always delayed here, which is annoying. 4.3 isn't even that big. Yeah, that's what I was saying. That's what I was saying. I can see 10s, I can see 7s. Okay, so the numbers are coming in now. All right, cool. So let's do this one together. A car has 5 gears. Given that the maximum speed of the car in the first gear is 22 kilometers per hour, the maximum speed in each successive gear forms a geometric sequence. The maximum speed of the car in 5th gear is 130 kilometers per hour. Find the maximum speed of the car in its 2nd gear, given your answer in kilometers per hour to 1 decimal place. So quite clearly, this is a geometric series problem, which isn't too bad. So let's do this one here. All right, so car has 5 gears. We know that the maximum speed of the kind of first gear is 22, and this is a geometric sequence. So what we're going to do is remember your general formula for an nth term of a geometric sequence is un is equal to ar to the n minus 1. And we're just going to use this here. So for example, the first gear is going to be u1. This is going to equal 22, which we know is also equal to a, right? So what we could say is that u1 is equal to 22, and that means that our first term is equal to 22. A is 22. Now, they've told us that the maximum speed of the car in the 5th gear is 130. That's just U5, no? U5 is equal to 130. So what that means for me is that U5 is equal to 130, right? And remember, a general term is AR to the n minus 1. So what we're going to say is that we've got AR to the n minus 1, which is going to be 5 minus 1. AR to the 4 is equal to 130. And remember, we also know that A is 22. So what we can say here is that 22 r to the 4 is equal to 130. And then that will allow us to calculate the common ratio of this geometric series. And then once we can do that, then we can figure out what they're asking for, which is the 2nd gear, right? So doing this is easy. We're going to just do r to the 4 is equal to 130 over 22. And then that means I need to take the 4th root of that number to get the common ratio. So I'm going to do that there, 130 over 22. And then doing this here is going to be the 4th root. I need to do that there. 4th root of that number, 130 over 22. That gives me 1.55 9, blah, blah, blah. And again, this isn't my final answer, so I'm never going to round it. I'm just going to put 1991 dot, dot, dot to show the examiner I'm not rounding. Now, the question asked us to find the maximum speed of the car in second gear. Second gear is U2, right? It's easy. So therefore, we could say that U2, which is the one in second gear, is going to be equal to AR, isn't it? AR to the n minus 1, so 2 minus 1, AR to the 1. We already had A, we've got R, easy. So it's going to be, A was 22, and then R is 1.5591, all to the power of 1. So that's just going to be our answer for the maximum speed in second gear. So I'm going to write 22. I already had that number stored, so I'm just going to write answer to the power of 1. I know I don't need to write to the power of 1, but I'm just going to do it anyway. And I get this number here. 34, was it 34? 34.3 kilometers per hour. And that's it. To one decimal place exactly. Yeah. And I'm just going to check the chat just to see that we're all good. That makes sense, guys. We're happy with that? Yeah. Yeah. Spite Riddler, 34.3 miles, 34.3. Call me Rizzle. Z Beats. Yeah. You guys are doing well. Yeah. All right. Cool. So we've done that. Let us continue. Now, the part B. Part B. Let's have a look at this one. All right. So, whoops. So this one here says the first two terms of an arithmetic sequence are 208 and 207.2. Given that Sn is the sum to n terms, find the maximum value of Sn. Now this one looks a bit weird because whenever they ask you for the maximum value, you obviously need n, right? Or they ask you for the sum to n terms, and you figure out value of n. But they're asking us for the maximum value of Sn. Well, how do we do that? Well, what I would do, especially when you're dealing with sequences and series, right? I like to visualize them. So, for example, what's happening here? Let's look at the pattern of the sequence. We've got 208. That's the first term, like that. And then if I want to figure out Sn, for example, like that, then I'm going to add on the next one, which is going to be 207. I don't need to put a bracket now, to be fair. 207.2 and so on and so forth. Now, what do we know here? We can see that our first term is A, right? 208. And the common difference, D, this is going down by 0.8, is it's going to be minus 0.8. And what you can do, especially when they ask you for formulas and stuff, Sn, just write your formulas out so you know what you're dealing with here. So for example, the sum to n terms is n over 2, and then 2a plus 1, 2a plus n minus 1 d, right? And then as well as that, you could also write the nth term sequence as well, which is just a plus n minus 1 d. All right. So I've got this Sn series here, the series for Sn, and they're asking me for the maximum value of it. So what I'm going to do is kind of inspect it, right? So if you think about it, I'm going to write out again. I've got 208 plus 207.2 and so on and so forth, right? Now, due to the fact that it's going down, we know that there's going to be a point where the terms in the sequence are going to turn negative, right? Now, when that happens, I'm going to be adding negative numbers to my sequence. So the moment I get a negative number, the sequence is going to be decreasing. Does that make sense? Are we happy with that? Yeah? Okay. Cool. Cool. Good stuff. So in this case, well, what do I do? Well, what I'd want to figure out is the value of the term in the sequence, right? Which is a zero. If it is zero, if it's not zero, then it's going to be thereabouts, right? We just need to figure out the final term, which is positive. And what you would do is say to yourself, well, what is the value? What is n, right? When un is equal to zero. That's what you'd want to do. Yeah. So essentially with this one, let me just see the chat. Can it n approach infinity? Da, 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 da. Okay. So now what do we do then? Well, the nth term is a plus n minus 1d. What I'm going to do is say, well, a plus n minus 1d, right, is equal to zero. I'm going to work that out. Now remember, we know what a is, we know what d is. It's going to be 208 plus minus 0. Actually, no, n minus 1 first. N minus 1, and then d is minus 0.8, and this is equal to 0. And I want to find the value of n where that occurs, because when that's the case, then I know anything after that is going to give me a negative value. So let's work this out. This one's not too bad. I'm going to move the 208 over, so I'm going to get n minus 1 minus times that is going to equal minus 208. And I'm going to divide by n, I'm going to divide by minus 0.8. So I get n minus 1 is going to equal minus 208 divided by minus 0.8. And then that way, I'm going to work that out first and then add one, right? Just because I'm doing, I know you guys, it's easy for you guys, but yeah, just because I'm making a live stream, I just want to be clear. So I'm going to work that out and see what I get. Minus 0.8. And that gives me 260. So I'm going to have n minus 1 is equal to 260. And that means that n is equal to 261. So that means that the 261st term of this sequence is 0. So there actually is a term in the sequence which equals 0. So again, we've got this here, like that. And then I'm going to just put this here. So put this here. So what this means for me essentially is that, well, fine. I've got a term that's going to give me 0, right? So I'm just going to write plus 0 here. And just to add more context to it, right? 0. Well, we know that the terms are going down in 0.8s. So this term is going to be positive 0.8, and this one's going to be 1.6, isn't it? And so on and so forth. So the moment I do another term after that, this is going to be minus 0.8, isn't it? So the moment I get that term right there, then the SN formula, the SN term is going to be decreasing, right? So what we could say here is, well, how many terms are here? Well, we know that this is the 261st term, right? All right, 261st time here. This is the 260th. This is the 259th, and so on and so forth. So we can see that the moment I add the 262nd term, the sum is going to decrease. So what we need to do here is just do the sum of the first 261 terms. And technically speaking, the 261st term is 0. So you could actually do S260 as well. These are going to be the same thing, just based on just based on this one alone. Yeah. So we need to figure out the sum to 261 terms. Does that make sense, guys? Just going to make sure. Let me just see. Just going to check the chat. Exactly. Wuju Juju. Yeah, that's exactly why. Yeah. Okay. So now we're gonna figure out those the sum to 261. It's gonna be S261 is gonna equal n over 2, which is gonna be 261 over 2, and then 2a. A was 208 plus n, which is 261, 261 minus 1, and then the common difference is minus 0.8. So all we're going to do is plug this in, and this will give me the answer. So I'm going to put this in and see what we get. It'll be 261 over 2, like that. And then it's going to be 2 bracket 208, and then plus 261 minus 1, and then minus 0.8, like that. Let me just make sure everything's correct. Yeah, that looks good to me. That looks good to me. And then I get this number here. Sum to 261 terms is going to be, what was that number again? 27,144. And that will be it. Does that make sense, guys? Happy with that? We just check the chat. I'm going to see if it, yeah. Got that in the chat. Okay, I'm just going to increase the volume so I know that it's all working. Right, cool. I'm just checking on my phone just every now and then just so I know that the sound is working and everything. But yeah. Okay. So got this here. And then now let us go to the next one, which is part B. It says, hence or otherwise, state the smallest value of n such that Sn is less than 0, right? So, what do we need to do here? With this one, we need to find the sum of values of n is less than 0. So, okay. So what we figured out, right? Let's just get this here again, right? What we figured out is that with this one, we copy this here. We figured out that this is the maximum value, right? When we add to the first 261 terms. Yeah. So I'm gonna write this is first term, this is second, um, this is third, blah blah blah, and this is the 261st term, isn't it? We worked that already, and this is gonna be the 262nd, and so on and so forth, right? Now, what's gonna happen is if you look at the pattern of the sequence, right, is I'm gonna be adding just the negative of each of these. So it's gonna be minus 1.6 for the next one after that, and it's gonna be all the way to the next one, which is going to be here. Let me put this here. And then all the way to minus 207.2, and then plus minus 208, like that. And then we need the sum to be negative, right? Now, when we sum here, right, it's positive, and then the moment we add terms after that, it's going to keep decreasing. If you think about it, that is going to cancel with that. That is going to cancel with that. And you want to basically cancel all of them. And then when you cancel all of them like that, you're going to get zero because all of the terms are cancelled. So at that point, well, how many terms are there? Well, if you think about it, let me just rub out the crosses just so it's not confusing, right? So this one here, how many terms were here? Well, this was 200. Let me just highlight it so it's clear, right? From here to here, right? There were 260 terms, isn't it? This is going to be 260 terms right here. And then well, from here to here, let me just rub that out as well so it's clear. So it's from here to here. There's 260 terms from here to here. And then there's a zero there. That's one term. That's one term, like that. And then from here to here, which cancels all of the terms in green, that's just going to be another 260 terms. And at this point, when I add all of these together, that's going to give me zero, right? Because the two greens are going to cancel out, right? Well, how many terms are there altogether? Well, that's just going to be 260 plus 1 plus 260. I know 260 plus 260 is 520, 521, right? So after, so I can say that S521, right, is just going to be zero because that will cancel with that. And I've got that term in the middle, which is one term. So 521 times is going to give me zero. The next term after is when it's going to become negative. So therefore, S522 is going to be less than zero. So like that. And so therefore, there's going to be 522 terms. And that's when it's first negative. So we could just say n is equal to 522. Does that make sense, guys? We just zoom out so we can see the chat again. We can see. No? We all good? Okay. Cool. Yeah, brilliant, Martin 2.0. Good stuff. So I think that's all okay. It's just Suva. You guys are trolling. Okay, cool. Let's see. Let's continue now. We've done that question. Now the next one is trigonometric equations, right? Forgot this here. Okay, yeah, brilliant. So this is the question here. What do we think about trigonometric equations and identities? Put a zero if you have no clue of this one, you find it very difficult, or put a 10 if it's very easy, very straightforward. I'm just gonna get answers for this one as well. Okay, cool, cool. So with this one now, I think the chat is gonna start rolling with the numbers. But yeah, I can say I love this 10. Finally, some trig. All right, cool, easy, brilliant. That's like cool, cool. Why tan all my days? No worries, tan is good. So we've got this one here. It says use the identity for tan A plus B to show that tan 3A is identical to 3 tan A minus tan cubed A minus 1 minus over 1 minus 3 tan squared A, right? For 4 marks. Now, firstly, it says use the identity tan A plus B. Now, what you should memorize, and I think it's in the formula sheet, by the way, but there's a couple of identities to memorize, which is just the addition formula here. And I've actually got this, actually made this a couple of years ago, by the way. So this is all on my Instagram. So if you want to just check out some formula sheets, head over to my Instagram. I made these about 5, 6 years ago, but they're very helpful. And as we can see with tan A plus B, it's just tan A plus tan B over 1 minus tan A tan B. So I'm going to copy that here and I'll put this here. So we're going to have this here and putting this in. This is going to give me, let me do this here. So yeah, with this one, I've got tan 3A, right? Now, if I want to use that formula, what you could do is say, well, you can actually break this down. And another thing to realize, if they ask you for 3A, right, think about what multiples that you deal with in trig. You deal with double angle formulas. So what you could actually do is just rewrite the tan 3A, right, as tan 2A plus A. Yeah. And then now what you want to do is just use the formula. So we could say in our case that our A is 2A and our B is A. So if I copy that there and I just use that formula, it's gonna be equal to all right, tan 2A plus A, like that is just gonna be equal to, if I copy that exact formula on top here, it's gonna be tan 2A plus tan A, right? over 1 minus tan 2a, and then tan a, like that. So let's look at the show that again. We need to show that we get that there, right? 3 tan a, so we need an a here. What we've got so far is 2 a's that we need to get rid of. Let me just make sure that's all good. Yeah, that's fine. So what you can do is say, well, fine, because I need a's in my show that the show that just have capital A's, I know that these need to go. And what you can do, this is actually a double angle formula as well. So you can derive it from this one by just making 2a plus a and doing the same thing. But I've got it here for you guys. The formula for tan 2a, the double angle formula, is 2 tan a over 1 minus tan squared a. So I'll put this here. So again, you can derive this. It's not in the formula sheet. The double angle formulas are not in the formula sheet, by the way. So yeah, doing that, I'm going to bring this here. So in that case, we can just replace that there, right? So we could say then that this just becomes, it's going to be tan 2a, which is going to be 2 tan a, over 1 minus tan squared a, like that. And then plus the tan a over 1 minus, and then the same thing, 2 tan a over 1 minus tan squared a, like that. And then I'm going to multiply, I'll put in a bracket so it's clear. I'm going to multiply by tan a, like that. And then what I've done here, let me just double check, that's fine, that looks good to me. So what I've got here now, I just need to tidy this up. So I'm just going to highlight this in green. So this is tan 2a, right, which is that one. And that's gone there, isn't it? If I compare that to what I've got. So we've got that there. And then now we're just going to try and manipulate this. So firstly, we've got fractions top and bottom. So we're going to combine fractions. So I'm going to combine fractions. So it's going to be, let me just do this here. Got another fraction bar. If I want to combine that fraction, I need the same denominator. So I'm going to times, if I put this over 1, for example, put this over 1, I'm going to multiply top and bottom by 1 minus tan squared a, isn't it? So it's going to be 2 tan a, 2 tan a over 1 minus tan squared a. And then plus, and then it's going to be tan a multiplied by 1 minus tan squared a over 1 minus tan squared a. And as you can see, those will cancel, you get the same thing. So these are equivalent, right? And then you're just going to do the same on the bottom. So to be fair, the bottom is going to be 1 minus, and then if I expand it, that's going to be 2 tan squared a over 1 minus tan squared a, like that. So I get that there. And then, yeah, what we can do now is just combine. So I'm just looking at the chat as well, just to make sure you guys are all good. But yeah, it looks like it's all fine. So I'm going to continue. And it's going to be, now if I do the numerator, I can combine these now. So what I'm going to do, I'm going to get another fraction bar like that. And then the numerator just becomes 2 tan a, like that. And then I can just expand that one, can't I? So that's going to be tan a minus tan cubed a, like that, over the same denominator, 1 minus tan squared a, like that. And then let's do the denominator now. Now that's a 1. I can write it as 1 minus tan squared a over 1 minus tan squared a, like that. Because we need the same denominator. Remember, this is the same as 1 over 1. The denominator is 1 minus tan squared a. So I can write the 1 as 1 minus tan squared a over 1 minus tan squared a. And then I've got this one, I've got this minus 2 tan squared a over 1 minus tan squared a, like that. So now, it's not too bad. Now let's tidy everything up, right? So I'm gonna get another fraction bar like that. The numerator, I've got a 2 tan a plus a tan a, that's 3 tan a, like that. And then minus tan cubed a, and then divided by 1 minus tan squared a, like that. And then I'm gonna divide this by, I can combine these now. That's just gonna be 1 minus tan squared a, right? Minus that 2 tan squared a, to be fair, over 1 minus tan squared a. And to be fair, tan squared a minus 2 tan squared a is going to be 3 minus 3 tan squared a. So I'm going to rub that out, and I'm going to replace this with minus 3 tan squared a. So I get this here. And then remember, this is a show that question. Always deal with what they've asked you with. So let's get the show that and just have a look. So this is the show that we've got here. And where are we? So let's just compare. So we are here right now. So we're here. We are here. And then we need to get that, right? So we are here. What do we need to do? This is good because we've got 3 tan a minus tan cubed a, and we've got 1 minus 3 tan squared a. So all you need to do now is we've got a fraction and a fraction. When you divide by a fraction, it's the same as multiplying by the reciprocal. Those will cancel out. So what I'm going to do actually, I'm going to copy this because it's a bit long, keep on writing it. So I'm going to copy this, right? That. It's going to be equal to that. And then I'm going to multiply by the reciprocal of the denominator. And that will give me 1 tan squared a, 1 minus tan squared a over 1 minus 3 tan squared a, like that. And as you can see, that cancels with that, and you're just left with what exactly they asked us to show. So we could say that therefore we could get 3 tan a minus tan cubed a over 1 minus 3 tan squared a, like that. That's exactly what they wanted us to show. Does that make sense, guys? So if something like that comes up, then yeah, it's just about dealing with your trig identities, knowing them very well, and then just yeah, rearranging. But I'm just gonna make sure we're all okay with that. Okay, okay, cool. So I think that's okay just from what I can see. So yeah, I'm gonna continue now. So we've done that. And part B says, hence solve for minus pi over 6 to pi over 6, tan 3x is equal to tan 4x. Now with this one, 4 tan x, sorry. So this one, whenever you see this, part A is always to show that, and then part B is always the hence solve. You always use what you've done in part A to help you solve part B. Now, as you can see, I've got a tan 3x here. Yeah? I've got a tan 3a here, sorry, right? And they've got a 3x here. So the only difference is that letter. So what we're going to do is we're just going to rewrite this equation here with that in terms of x, essentially. So let me just put this here. Do I have room? Yeah, have room. Yeah, this is definitely going to be over an hour, to be fair, if I do the other questions as well. So apologies, guys. But yeah, doing this one. We've got that there, and then we're trying to solve that equation. So I'm going to get that here as well. So doing that, gonna put this here, and then what we're gonna do is say, well, fine. If that's the case, then we could say that this here is just the same as 3 tan x minus tan cubed x over 1 minus 3 tan squared x, like that. 1 minus 3 tan squared x is equal to 4 tan x, right? And then now this is good because we can just multiply and then get a what is it? A cubic, right? As this guy's cubic. So let me try a 3 here. So now if I times by that, I'm going to get 3 tan x tan cubed x is equal to, and if I multiply that, I'll do it in steps just so it's clear, to be fair. 3 tan squared x, like that. And then it's going to be 4 minus 12 tan squared x, like that. And then we have 3 tan x minus tan cubed x, like that. And then what we can do, let me just make sure that this is all okay. Times by that, that's a 4. Oops. Oops, I forgot the tan x. Sorry about that. What's going on with me today? Apologies. Let me just move that there. That should be a 4 tan x, isn't it? Should be tan x here. And then that would be 1 minus 3 tan squared x. And then now doing that, that's going to be 4 tan x minus 12 tan cubed x. Like that. And then now, just to tidying that up, what we're gonna do, I'm gonna move everything from right to left. So if I move everything from right to left, I've got minus 12, I'm gonna add that on. That's gonna be a plus 12. So I'm gonna get 12 minus 1, that's gonna be 11 tan cubed x, like this here. And then if I move that over, that's just gonna be 3 tan x minus 4 tan x is gonna be minus 10 x. So I get this here, and this is equal to 0. And then what we can do, yeah, I just thanks for that discipline and determined. Yeah. Appreciate it. But yeah, now we can just factorize. Now, by the way, this is another thing as well. When you're here, don't ever divide by the common factor. Always take out the common factor because you're going to lose a solution. So it could be 11 tan squared x here minus 1 is equal to 0. And then now we've got a solution here. Tan x is equal to 0. And we've got this one here. Right? And let's just remember our range. It's between minus pi over 6 and pi over 6. So this one is going to be tan x is equal to 0. right? Doing the tan inverse of that, that's going to be tan inverse of 0. And am I in degrees? I'm in degrees. I need to change it to radians. So let me do that quick. 2 radians, tan inverse of 0. Tan inverse of 0 is going to be 0, yeah, obviously. So x is equal to 0 is one solution. Now remember the periodicity of tan, right? You could use the cast method or the graph, whatever you prefer. What I like to do is just memorize them. So I know that the values are going to repeat every 180 or pi. So it's going to be 0 plus pi, and then 0 plus 2 pi, and so on and so forth. Now the range is between 0 and pi over 6. So the only value here is going to be 0 that works, to be fair, right? So it's going to be x equals 0 because when I plug that in, you can try, they're going to be outside of the range. So x is equal to 0 there. And then now we need to just solve the other one, which is going to be 11 tan squared x minus 1 is equal to 0. So that's one solution. And I need to solve 11 tan squared x minus 1 is equal to 0. So that means that tan squared x is going to equal, add 1, divide by 11. And then I'm just going to square root. So tan x is going to equal plus or minus the square root of whatever that is. And that's probably going to rationalize for me. So I'll do that in my calculator and see what we get. So tan inverse of 1 over 11, like that. Whoops. That's going to give me, oh, sorry. I haven't even square rooted. Apologies. Plus or minus the square root of that there. Square root of 1 over 11. That equals root 11 over 11. So it's going to be plus or minus root 11 over 11. And I'm going to take the tan inverse now. So doing that is going to be tan inverse of the first one is going to be, I'll just write it so it's clear. We're going to do tan x is equal to root 11 over 11. Figure out the values are there. And then tan x is equal to minus root 11 over 11. Figure out the values there. And doing this is going to be, the first one is going to be tan inverse of root 11 over 11. And that gives me 0.292. X is equal to 0.292. And remember, the range is between minus pi over 6 and pi over 6. So what you could do, what I like to do as well, is just to have a gauge of what actually that number is. Pi over 6, right, is equal to 0.5. So approximately 0.52, right? Approximately. So the moment I try and find another value, remember it's going to be 0.292 plus pi. Pi is like 1.57. It's going to be outside. And if I do it on the other side, it's going to be outside. So this is the only value here between minus pi over 6 and pi over 6. So that one's done. And then the last one is just going to be, well, all I'm going to do is just going to change it to a minus now to figure out what that is. And it's minus 0.292, right? So for that one, I'm going to get x is equal to minus 0.292. And the exact same thing, if I add pi to that, or take pi to go the other way, it's going to be outside the range of pi over 6 and minus pi over 6, right? Which is approximately 0.52. So these are our only two values here, right, for these two equations. So we've got all of the values. So therefore, your final answer is just going to be x equals 0. Whoops. X is equal to 0, 0.292, and minus 0.292. And that's it. Does that make sense, guys? I'm just going to check the chat and see how we're getting on. Let me just see. Just check the chat. Yeah. And let me just double check, by the way. Hold on. Let me just double check what that value is, to be fair. Oh, apologies. To three decimal places or three significant figures, that's 0.293, by the way. My bad. That should be threes there. Let me change that. That should be threes there. So I'll put 9-3 here and then do that. Like that. That should be 9-3. That should be 9-3. That should be 3 there. 3, 9-3. So that's it. Yeah? Cool. Right. So that's done. That's done. That's 3 questions done. It takes a while to do these questions. We've got 2 more, so we're definitely gonna overrun. Apologies, but yeah, we've got this one here. These ones aren't too bad, but yeah, differential equations. What do we think of this one? Put a 0 if you think it's easy. So put a 0 if you think it's hard. You hate them, hate modeling questions, or put a 10 if this is light work. If you see this come up, this is not a problem whatsoever. Absolutely easy. Yeah. Okay. You can see zeros. Is it always in radians? I think it is, but you can just check with your teacher. Yeah? I can see zeros, I can see tens. All right, let's go through this together and see how we get on. So let's read it. It says, Figure 4 shows a vertical cylindrical tank of height 225 centimeters containing a liquid. The liquid is leaking out of a hole P in the base of the tank, as we can see. At time t minutes after the leaking starts, the height of the liquid in the tank is h centimeters. The rate at which the height of the liquid in the tank is decreasing at any time t minutes is modeled as being proportional to the square root of the height of the liquid in the tank t. When t equals 0, h is equal to 225. When t equals 125, h is equal to 100. The liquid stops leaking from the tank when h is equal to 0. By forming and solving the differential equation, show that the model leads to the equation h is equal to 15 minus 0.04 t squared, right? Where t is between 0 and a, I will need to state the value of the constant a, right? This is a 7 marker. Now, these ones, I'm telling you guys, it's not too bad, right? So, firstly, we need to form, because remember, they've told us to form a differential equation, right? That's the first thing. And you always form a differential equation by looking at what they've given you, right? Now, a differential equation is just literally an equation with a derivative in it. So we need to figure out some derivatives here. Now, they told me here that the rate at which the height of the liquid in the tank is decreasing by, right, is proportional to that, the rate. Now, I always tell my students this. If you see that word rate anywhere in A-level maths in any paper, that word rate just literally means dy over dx. It just means a derivative, right? Obviously, I'm just using y and x because that's the main thing that we use. But yeah, it says the rate at which the height of the liquid of the tank is decreasing. So the rate at which the height. So rate which the height for me, when I look at that there, that just tells me that, well, the height is changing, dh, with respect to what? Well, time is going on. That's dh by dt right there. What I'll do actually, just so it's clear, right? I'll copy this and put this here. So I'm going to say that got this here, rate at which the height, that there, hold on, that there tells me that that's dh by dt. So I hope that makes sense, right? So I'm going to put this there. That part just means dh by dt. This part means dh by dt, like that. And then this is equal to what? It says it's being modeled as being proportional to the square root of the height. Well, proportional, we know that means k. Square root of the height is square root of h. Proportional is directly k root h. No? So therefore, we're going to have k root h here. And that's literally our differential equation formed. Does that make sense, guys? Let me just zoom out a bit so you can see everything. Just want to make sure we're all okay with that. And I'm just going to go to the next part. Yeah. And as well as that, right, it does say that it's decreasing. So technically, because some of you may be thinking, right, well, if it's decreasing, it means that the gradient is negative. So yeah, what you could actually do is say, well, another way you could write this is that you could say dh by dt is going to equal minus k root h. Now, what you can do is solve either one of these. What this one will do is you're going to solve for k, and k is going to be negative, right? Because it's decreasing. Or if you solve this one, k is going to be positive, and then the minus is taking care of it for you. Yeah. So does that make sense for anybody that's wondering about minus k and k root h? You can do it two ways. You could either solve this one, and your value of k is going to be negative, or you could solve this one, and k is going to be positive, but the minus will make it negative overall. We happy with it? Yeah. Cool. So what I'm gonna do is yeah, I'll just solve the first one, and we're gonna see that k equals a negative number, right? Just so you know it works. Yeah. So we've got this here. Now we formed our differential equation. Now let's just see what the question says. They've given us that there, initial conditions. So let's solve this first, right? Now, how do we solve a differential equation? We're just going to separate the variables. Now, how do you do this? You're going to have the DHs with the H's and the T's with the T's. If there are T's, if they're not, you're going to put it with the constants. So I'm going to divide by root H. So I'm going to get DH over root H is equal to K dt, right? Now I've got this here. Now what I can do is say, well, fine, that's a root H, by the way. So I'm going to just write this as 1 over root H dH, and this is equal to K dt like that. And to be fair, from here, once you've separated the variables, you can put integral signs from here. So we're going to integrate both sides. But now with this one, that we can rewrite using our index laws. That's going to be h to the power of a half. This is going to be h to the minus 1 over 2 dh. And this is going to be equal k dt like that. And then now, once we do this here, then what did you get? What did you get on your A level maths exams? I got an A star a long, long time ago, 2015, so 9 years ago. But yeah, Adam, that's correct. I can see your initial conditions. You've got them good. So yeah, now we're just gonna integrate both sides. So if I integrate this, we have to add 1 to the power. Adding 1 to minus half is going to give me a half. I'm going to divide by the new power, and then it's going to be equal to. Now, integrating this, guys, I see a lot of people get tripped up with this. K is a constant here. So, for example, if it was, for example, E dot G, let's say it was 4 dt, then the integral would just be 4 times whatever the variable is 4t. So if it's K, it's just going to be kt. And then we add our constant of integration. Now, when we're here, we've done this. Let me just tidy this up a bit more. Dividing by a half, the same as times by 2. So 2h to the half is equal to kt plus c. Now, when we're here, this is what we call a general solution of a differential equation because we don't know the constants. And then to get our particular solutions, that's when we figure out what the constants are. And to find the particular solution, you need initial conditions. And luckily with this one, they actually stated them, right? They said when t equals 0, h equals 225. When t equals 125, h equals 100. So therefore, we can plug this in and see what we get. So I'm going to plug this in and see what we get for each of them. So I'm going to plug this in here. And now remember, this is a show that, by the way, we need to, we've figured out what differential equation is. We need to figure out what the values of the constants are. So I'm going to need to put this here like this and see what we get. And then put in this here. So now what we can do is just figure out what the values of the constants are with this here. So firstly, when t equals 0, h equals 225, I'm going to plug that in into this differential equation here. That will give me 2 lots of 225 all to the power of a half is equal to k lots of 0 plus c. So c is going to be equal to whatever this is here, and I'll put this into my calculator and see what I get. 225 to the power of 1 over 2, like that. And that gives me a 30. So our constant c is 30, and that means we can update our differential equation and say, well, so far we've got 2h to the 1 over 2 is equal to k t plus 30. And then now we could use the other set of initial conditions to figure out what k is. So it's not too bad. Doing this is going to be 2 lots of 100 to the power of 1 over 2 is equal to t is 125. I put in there, it's going to be 125t is equal to plus 30. Now that, let me just double check. T, 125t, sorry, should be k, isn't it? Because t is 125, so it's going to be 125k, like that. Because I'm trying to figure out what k is. Yeah? So now, working this out, well, that's just the square root of 100. That's 10. 2 times 10 is 20. That's 20. It's equal to 125k plus 30. And then if I move the 30 over, that's going to be a minus 10 is equal to 125k. And then dividing by that will give me the answer. So I'm going to do minus 10 over 125. And that gives me a minus 2 over 25. So we can see that k is equal to minus 2 over 25. Okay, as you can see, remember, we did not put a negative sign at the beginning of our differential equation, but it doesn't matter because it will give it to us here. If I did this one, if I solve this differential equation with the minus already, then k would be the positive of what I've got, right? So positive of 2 over 25. Hope that makes sense. Yeah, good stuff. So now we've got k, we can then complete the differential equation and say that the complete model is going to be 2h to the 1 over 2 is equal to k, which is minus 2 over 25, t plus 30. And now remember, we've solved it, but we need to get into a specific form. I think I already put it here, actually. Where is it? Yeah, right here. Like this here. Copy and then paste like that. So now we've solved it. This is easy now. We just need to get into that form. So that's not a problem because what we can do, what I'm going to do is I'm going to write this as a decimal because the answer is in a decimal. So it's going to be 2h to the 1 over 2 is equal to minus, and what's that? What's 2 over 25? 0.08. T plus 30. And now you can see that this is the way done here. Because now if I divide by 2, I'm going to have h to the 1 over 2 is going to equal minus 0.04t plus 15, like that. And then now to get h, we just square both sides. So I'm going to square both sides. So I'm going to have a big square like that, obviously. And then obviously, I'm just going to write in the form. 15 is positive. I can put that first. Minus 0.04t. And that's it. Does that make sense, guys? We happy with it? Yeah, good stuff. Good stuff. And then now, remember, we also needed to figure out what the constant a is. Now, remember what we're dealing with here. Always think about the context of the question, right? They've told us that we've got a cylindrical tank, right, where the water's leaking, and we figured out the formula which connects the height at any time, right? Now they've told us that the liquid stops leaking for the tank when h is equal to 0. That's going to be the maximum time, no? So all we're going to do is just make h equal to 0, figure out what t is there, and that will give us the value of a. So that's pretty easy now. So I'm just gonna let me just copy it one more time, just so we have it here, and then putting this in is gonna be yeah. So we just need to make h equal to 0 now to get a. H is equal to 0 would mean that we're gonna have 0 is equal to 15 minus 0.04t all squared, and then we're just gonna figure out what t is. Square rooting is going to be 0 is equal to 15 minus 0.04t. Adding on the 0.04t is equal to 15. That means that t is going to equal 15 over 0.04. Putting that in is going to be 15 over, let me do it here so you guys can see it as well. 15 over 0.04. That gives me 375. So therefore, t is equal to 375, and that's going to be the maximum time of the height of the water when it's falling out of the tank. So we could say that therefore A is equal to 375. And that's it. Does that make sense, guys? Zoom out. Sorry. Let me zoom out from what I can see. I can see zoom out in the chat. And that's part A. That's 7 marks in the bag. And I'm just gonna loud it so I know that it's still okay. Yeah. Cool. Cool. Wait, why do you make it 0? Because I can just see why do you make it 0? It's because they told us that the height, sorry, what does it say? The liquid stops leaking from the tank when h is equal to 0. And we know that this value, the values of t are going to range, right, between 0 and some value whereby the height, whereby there's going to be no more water in the tank. So we made h equal to 0 to figure out when that happens for t. And that will be the maximum time. Yeah, hope that makes sense. Yeah, I'm just having a look here. First equation, please, again. First bit of the equation again. Um, I don't know what that means, but I think I'll just put this here. So this is the first bit of the equation, and then we just separated variables, and then yeah, we just separate variables integrated, and then we just got our values by using initial conditions, and then we got our k, we got our c, and then we use algebra to get the form, and then we just plug this in here. So hopefully that makes sense. So hopefully that wasn't too bad of a question. And then we got part B, which says find, according to the model, the time taken for the height of the liquid in the tank to decrease from 100 centimeters to 50 centimeters. Give answer to the nearest minute. Now remember what we figured out. Remember, context is always important. We've got a model of the height of the tank, the height of the water in this tank. It's equal to h is equal to 15 minus 0.04 t all squared, right? Now, they've asked us to find the time from when it decreases from 100 centimeters to 50. So what we could do is just plug in h equals 100 solve for t, plug in h equals 50 solve for t, and then take the difference. But actually, remember at the beginning, they actually told us that when t was equal to 25, h is equal to 100, right? So we actually know when this happens. This happens at 125 seconds, right? But just to convince yourself, you can plug in t equals 125 into there, and you're gonna get 100 out, right? Because they told us. But yeah, just to be sure, you can do that. Just to clarify for yourself if that doesn't make sense. But yeah, what we need to do now is figure out the value of t, right? When h is 50 to figure out the time and when that happens. So we're just gonna say h is equal to 50 for this one right here. For this one right here, we need to figure out the time when it happens. 50 is going to equal 15 minus 0.04t all squared. Solving that, square rooting that's going to be 50. Root 50 is going to equal 15 minus 0.04t. And then what I'm going to do is I'm going to add 0.04t minus the root 50. So I'm going to get 0.04t is going to equal 15 minus root 50. And then now I'm going to divide by 0.04 to get t. 15 minus root 50 is going to give me and then divided by 0.04. That's going to give me the value of t for when the height of the water is 50 centimeters. I'm going to put this here. 15 minus root 50 over 0.04 is going to equal 198.2 blah blah blah. So I'm just going to equals 198.2 blah blah blah. Right, so essentially what's happened is that we've got a cylinder. Was it a cylinder? Yeah, it was a cylinder, right? So basically we have a cylinder like this, like that. It's really bad, but you guys get the picture. The height of the water was what was it? It was 100, right? H equals 100 here. And then later on, this is at a time of 125 because they told us. Yeah, they told us at the beginning, t equals 125 over there. And then obviously later on, we've got the same cylinder and the height is decreased, right? To, what was it? 50, right? Half of it, like that. And I'm going to say that's 50. H is equal to 50. And then this is 198.2 seconds. So the answer for when that happens, or how long did it takes, let's read it again. Find the time taken for the height to decrease from 100 to 50. It's going to be the difference between these two numbers. So the answer is going to be the time is going to be equal to 198.22 blah blah blah. Take away 125. So all I'm going to just put this in. I've already got that stored to be answer minus 125, which is equal to 73.22. 73.22, sorry, like that. And then to the nearest minute, that's going to be 73 minutes. And that's it. Does that make sense? Happy with that? Cool. Cool. So it's 8:36. I've got one more question prepared, parametric integration. I did say it was gonna be an hour, but I did overrun a bit. So I'm gonna continue, but I just want to see, do you guys want me to continue? Let's see. Yeah? Okay. Hopefully you guys say yes, because if you say no, that would be embarrassing. Yeah, cool, cool. All right, cool, good stuff. So okay, cool. I can see yeses. I can see yeses. All right. Final push. Final push. Let's go. Parametric integration, guys. What do we think of this one? Put a 0 if you think, listen, I'm cooked if this comes up. Or put a 10 if, listen, if this comes up. Easy. This is light work. What do we think? Okay. Cool. Cool. All right. Let's see. Let's see. I'm just looking here. All right. Let's see. So it says figure 3 shows a sketch of the curve of parametric equations x is equal to 4 sine t and y is equal to 3 sine 2t between 0 and pi over 2. The region R shown shaded in figure 3 is bounded by the curve, the x-axis, and the line with equation x is equal to 2. Find the exact area of R for 7 marks, right? Now, normally with these types of questions, they break it down. They say, show that the integral is this and that. They haven't done any of that. They just said, boom, find the integral, 7 marks, right? So, firstly, what are we dealing with? We're dealing with a parametric equation, right? And we need the area of this region R. So, what I like to do whenever I'm dealing with parametric integration, right, is, well, if I look at it in a Cartesian form, right, I'm going to be integrating this function here, whatever it is, right? I'm going to call it y actually. I'm going to call it y. You'll see why. I'm going to call it y with respect to x, right? And it's going to be between, in this case, it's going to be between 0 and 2, right? That is in Cartesian form. Now, if you want to integrate parametrically, there's a formula for it. You can memorize it, but there's a way that I like to memorize it, right? Is I know that parametric and Cartesian forms are equivalent, right? So what you'd want to do is say, well, fine, let me not even put implies, I'm going to put equals, right? This is going to equal the integral of y, and then you put dx over dt here, right? You multiply y and dx over dt with respect to t, right? And if you think about it, right, the dt's are going to cancel and you're left with just y over dx. Sorry, not y over dx, but y dx, which is equivalent to that one. Yeah. So that's how I like to remember it. You guys can do it your own way, but yeah, that's just something I remember. So yeah, the integral, if you want to integrate parametrically, is just y multiplied by dx by dt with respect to t, right? So if I want to integrate this, I know that I'm going to have to do, I'm going to write out here again. So it's going to be integral, put this here, going to be y dx over dt. So now I need to just figure out what y is, what dx dt is, and times them together. But before that, though, we need limits, right? Now remember, in our case, in Cartesian form, right? Remember, the limits of integration are x values. We're integrating between x equals 0 and x equals 2. We need the corresponding values for t. Yeah? So how do we find that? Well, if you think about it, remember, parametric and Cartesians are equivalent. If I was integrating between x equals 0 and x equals 2, there's going to be corresponding values of t which which correspond to that, right? So what we're going to do is say, well, fine. I know, I'll just put this here. Do it one more time. It's going to be between 0 and 2 of y dx. This is in Cartesian form. I'm going to write Cartesian form. All right, cart for short. I'm going to write parametric here. Parametric here. Now, I know that it's between the limits. I'm going to write limits here are going to be between x equals 2 and x equals 0. But remember, parametrically, x is 4 sine t. So all I need to do is just solve. I'm going to write since x equals 4 sine t, right? All I need to do is just solve 4 sine t is equal to 2, right? And 0. And that will give me the values of t, our limits, right? So I'm just going to check that just to make sure we're all good with that. Okay, cool. So let's solve this now. Now with this one, remember, by the way, the range was between 0 and pi over 2. So I'm going to just solve both of these here. 4 sine t is equal to 0 because these are what x's are. Solving this one, it's going to be sine t is equal to 2 over 4, which is a half, right? So I just do sine inverse over half to get what t is. Sine inverse of 1 over 2 gives me pi over 6, right? So that means that t is going to equal pi over 6. And that is in the range of 0 to pi over 2, isn't it? Because pi over 6 is smaller than pi over 2. And you're not going to get any others. So the first one is going to be pi over 6, right? And then this one is easy. That's sine t is equal to 0, right? The sine inverse of 0 is just 0. T is equal to 0 here. And again, that's within our range, right? Because 0 is inclusive. So now we've got our limits of integration in terms of parametrically. So I'm going to just put this here because that's always important, getting the limits. Yeah, so we got this here. And yeah, put this here. We now know that we're integrating between t equals 0 and pi over 6. So now what's left is just to figure out what y is, figure out what dx dt is times then, and then get the integral. So let's go ahead and see what we've got here. Let's get the parametric equations again. So in that case, okay, this is not bad at all, guys, because we're going to have this here. It's going to be the integral. Let me write this here. Let me zoom out a bit. So yeah, that's fine. And then integral is going to be it's going to be between 0 and pi over 6. So we just check. Yeah, 0 and pi over 6. Y is 3 sine 2t. So I'm going to write 3 sine, or you know what, let me not even, I don't need the bracket to be fair. No, actually I'll put it 3 sine 2t, that's y. And then we'll dx by dt. Well, if x is equal to 4 sine t, x is equal to 4 sine t, then dx by dt, that's a standard derivative. That's just going to be 4 cos t. So I get it here, and I can put this here. 4 cos t, and then dt. Now this is going to give us a couple of marks because we've set up our integral, right? So what do we do now? Well, we need to integrate this. Now, I'm going to tidy this up a bit. So I've got, what have I got? I've got between 0 and pi over 6. I've got 3 times 4, that's 12. I've got 12, and I've got sine 2t cos t. Now, I'm looking at this. How on earth do I integrate that, guys? Anybody have any suggestions? How do we integrate something like that? Well, when I look at this for me, right, I've got a double angle formula here, right? Sine 2t is one thing that you should know. This is equal to 2 sine t cos t. 2 sine t cos t, like that. So doing that, I can replace that. And this is quite helpful because I'm going to have 12 and it's going to be 2 sine t cos t, right? And I'm going to times by cos t again. Could be dt, like that. And I'm just looking here, 0 pi over 6, like that. And I'm just double checking. Yeah, good stuff. And then now tidying this up, well, we've got 12 times 2, that's 24. Sine t, right? And then cos squared t dt. and I've got pi over 6 between and that there. So we're here. Yeah, good stuff, big boys. Yeah, we can take the 24 out, to be fair. We can take it out. Um, from what I know from students, they prefer to leave it in. So I'm just going to leave it in, but you can take it out. Just do 24 times it, but I'll leave it in. But yeah, so how do I integrate something like this? Now, this is another thing that you guys should be aware of, right? Now, I'm integrating something with signs, and then I've got a power here. Now, when you see this type of form, and it's actually in the book somewhere, I think it's like if you have an integral of f dash of x, right, multiplied by fx to the power of n, right, dx, for example, then you always say, well, you're just going to try, and you're going to increase this power. You're going to try y equals f of x to the power of n plus 1. Yeah, and you're going to see what this all means. Don't worry. So in this case, this is actually a reverse chain rule problem. And I'll show you why, right? Because if I inspect this, what I notice is that, well, I've got a cosine here. I know when I differentiate cosine, it gives me minus sign. I've got 24 sign, but that doesn't matter. The fact that I've got a sign there tells me that it's a reverse chain rule problem. So what I'm going to do is if I compare this here, I've got a squared here, got an n here. This tells me I need to increase this power. So what that tells me that I'm going to try set y equal to, and I'm going to write cos t, and I'm going to write all to the power of 3. Can we see I've increased that power there? And then what's going to happen with the reverse chain rule is very simple. This is what you're going to do. You're going to differentiate this. If I differentiate this, right, it's going to be dy over dt. This is a chain rule problem. 3 is going to drop to the front. It's going to be cos t. I'm going to take 1 away from the power 2. And then I'm going to times by the derivative of what's inside here. And that's going to be minus sine t, like that. So in that case, I'm going to tidy this up. It's going to be minus 3. I'm going to put sine t here. And I'm going to write cos squared t like this. And then now, this is the derivative. I know that the derivative and the integration and differentiation are reverse processes, right? So that's not dx, that's dt. Yeah? So what that tells me that, fine, well, I know that based on this here, if I integrate that, I'm going to get that. So I can say, well, I'm integrating minus 3 sine t cos squared t, right? dt, like that. And I know that when I integrate that, well, that's just the derivative of that. That's just going to be cos, and I write it like this, cos cubed t, right? Plus c, obviously. Yeah, but I'm just going to leave it for here because it's a definite integral we're dealing with. But yeah, does that make sense, guys? Yeah, because it's just literally the reverse chain rule. I've differentiated something. That means when I integrate whatever I've differentiated, I'm going to get what I got at the start. Yeah? And now all you do is this. You're going to compare this with the integral that we've got. We've got the exact same thing, but we've got 24 instead of a minus 3. So I'm going to write 24 here, sine t, cos, cos squared t, right? dt. That's what we're integrating. Well, what is the difference between these two integrals? I've got a sine t there, I've got a cos squared t. The only difference is that constant. How do I go from a minus 3 to a 24? You're going to times by minus 8. And now if that's the case, then all that means is that we're going to have to times this by minus 8, which was the integral, right? We're going to times that by minus 8. So therefore, the integral of that is just going to be minus 8 cos cubed t. And obviously plus c, but we're dealing with a definite integral because we've got limits, but I'm just going to put this here. Does that make sense? Yeah? And Madison Collis, yeah, that's correct from what I remember. Yeah? So yeah, that's all you're doing with the reverse chain rule, guys. And always make sure you're able to spot the form. You have a function with a power, and then you've got its derivative next to it. Obviously, cos differentiates to minus sign, but the minus doesn't matter. The fact that you've got the sign that indicates to you, tells you that you need to use the reverse chain rule. So that makes sense. So now we've got that. It's easy now because all we're going to do is we're going to say, well, remember, by the way, let me put this here. Let me copy this here because we're pretty much done now. Because now we've actually got the integral. So I can paste this here. And yeah. Okay. So now got this here. We're going to be doing limits like this, like that. It's going to be between 0 and pi over 6. And we know that what this integrates to, this is just minus 8 cos cubed t. So I can put minus 8 cos cubed t, like that. And then now I just have to plug in the limits and we're done. Right? It's easy. Brilliant. So now doing this, it's going to be minus 8 cos, and I'll write like this, by the way, because I'm plugging into my calculator. Pi over 6, like that, all cubed, minus and then it's going to be minus 8, and then cosine of 0 all cubed, like that. Now, let me just see where the cubed is. Yeah, that's fine. Yeah, that's fine. And then close bracket there. So now I just to work these out. This is not too bad. So what I'll do is I'll put this into my calculator and see what I get. So I'm just going to put this in. So that's going to be, let me just zoom out so you can see the working out as well, by the way. For that one, the upper limit is going to be minus 8, and then it's going to be bracket cosine of pi over 6, and then it's going to be cubed, like that. Plugging that in, the calculating radius, that's fine. That gives me minus 3 root 3. Minus 3 root 3. And this one here, the two minuses make a plus, to be fair. And then plugging that in, to be fair, I already know what that is. That's the cosine of 0 is 1, no? 1 cubed is 1. That's going to be 8. That's going to correct answer. I'm just going to do it just to be safe. 8, and then I'm going to do, or what I'm going to do, I'm just going to do cosine of 0 all cubed. And then cubed there, that's 1. So it's just 8 times 1, essentially, isn't it? Which is just going to be that. Minus 3 root 3 plus 8. And then obviously I can rewrite this as 8 minus 3 root 3. And that's it. Well done, Aaliyah. I can see Izzy got it correct. Juice, slight work, guys. Yeah? Does that make sense? Let me just zoom out so you can see all of the working. We happy with that? Let me just, I'm going to loud up my phone so I know that the sound's still going. And then obviously I can rewrite this as 8 minus 3. Cool. Okay. Cool. So yeah, that's pretty much it for the questions. Yeah. What I'll do, hopefully vectors comes up, doesn't come up in paper 1, but I'll definitely try and do that for the next one. Yeah? So, let me just see light work, common core for claw tomorrow. All right. Now, proof as well. Forgot to do proof. But what I'm gonna do is these are the questions done. I've got a couple of tips for you guys, right? So I've got a couple of tips. So firstly, my first tip for tomorrow is show that questions, right? I get this a lot with students, right? I'm in a lesson with a student. They say they can't do a question, and it's a show that, and then they say they can't do the rest of the question, right? One thing that you should always remember is that if you can't do a show that question, it doesn't mean you can't do the rest of the question, right? That's super important. So I've got an example here. We've got this mad crazy question, right? Which is probably going to come up, by the way. This was in June 2022 at Excel. So show that you get this there. Now, looking at this, it's difficult. If you can't do it, that doesn't mean you can't do part B. Using algebraic differentiation, find the value of R where S is a stationary point. That's just gonna mean that you're gonna just differentiate this here. The S over dr is equal to 0, right? So for R, blah blah blah. By further differentiation, prove that this value of R gives a minimum surface area. That's exactly what we did in the first question of this live, right? You can easily score 6 marks out of 10, even if you can't do part A. So that's just something I really want to stress. That if you see a show that question tomorrow, that does not mean you cannot do the rest of the question. Yeah. And then what else do I have? I think I've got other couple of examples here as well. Yeah, here as well. These are show that you get the sum to end terms. That's in my TikTok, by the way, if you want to watch that. But that doesn't mean you can't do part A and part B. This one again, show that you get that. That doesn't mean you can't do the rest of the question. That's super important, right? And then yeah, that's one of them. And then yeah, recurrence relations, which comes up. I haven't covered it in any of the lessons, but I have got a couple in my in on my TikTok, and I've actually done this exact same question on one of my other it's not a live stream, but it's a video on my channel that you can watch. I've actually done this here, but recurrence relations, right? This will come up a lot. Now with this one, they always ask you these types of questions whereby they give you the sum and then you have to just basically use patterns to help you out. So this one quite quickly, I'll just run through it very quickly. We've got un plus 1, 1 over un, and u1 is 2 over 3. So that means, for example, u1 is going to be 2 over 3, and then u2, right? u2 is going to be 1 over u1. That's going to be 1 over 2 over 3, which is 3 over 2, right? So we're going to get 3 over 2, and then u3 is going to be flipped over again. So it's going to be like that, right? And what's going to happen is that, well, there's only going to be two distinct terms of this sequence, but they're asking us for the sum to 100 terms. Don't panic. This is easy. If you look at this here, if we're looking for the sum to 100 terms, right? Well, I know that every 2 terms, I get 2 over 3 plus 3 over 2. This is 2 terms here. And we're trying to get this to 100. Well, how many 2's go into 100? There's 52's that go into 100. So the sum for this one, so I think I'm running out of room, right? is just going to be equal to, all right, here, the sum from r equals 1 to 100, right, is just going to be equal to, well, it's going to be 2 over 3 plus 3 over 2 times by 50 of them, because there's 2 of them and you're trying to get to 100, like that. Whoops, put it like that. And I'll put a 50 here. Yeah, that is something that can come up. Now, this one is quite nice because of the fact that it was a number that goes in, but you could also get stuff like this as well, whereby, for example, it says r equals 1 to 80. And this one, I can't remember what the values are, but it was a periodic sequence of order 3. So for example, I'll give you an example, right? Let's just say I had A1 is equal to 3, A2 is equal to 5, and I don't know, A3 is equal to 9, for example, and I want the sum of the first 80 terms. Well, what do I do here? Well, in this case, if I want to do this at r equals 1, AR from 80, right? The first 80 terms, or what's happening here? I've got 3 plus 5 plus 9, and then I'm going to keep doing 3 plus 5 plus 9, for example, and so on and so forth. I need to do this 80 times. Well, we can see that we've got 3 distinct terms, right? So what we need to ask ourselves, we've got 3 terms here, like that, 3 terms, 3 terms. Sorry, my handwriting is, I'm just looking at the chat at the same time, yeah? 3 terms like that. Well, what happens here? I'm summing from 1 to 80. Well, you need to ask yourself, well, how many times does 3 go into 80? Do 80 divided by 3. 80 divided by 3 is equal to 26 point something. So 26 times with a remainder, right? 26 times by 3 is 78, right? So what that means is that to work this out, we need to do this 26 times, and that will give me the first 78 terms. 26 multiplied by 3 plus 5 plus 9, right? This is going to give me 78 terms, right? But they asked us from 1 to 80, so we need 2 terms more. So we're just going to do the next 2 terms of this sequence, which is going to be, we're going to start again. It's just going to be the 3 plus the 5, like that. So the sum for this one, by the way, this was just a random example. I made up these numbers here. This is not the actual answer to the question, but it's just something to just show you. It's going to be 26, lots of 3 plus 5 plus 9, because these are 78 terms here, plus the next 2 terms of the sequence because it repeats after the 9, 3 plus 5. And that will be whatever this is. I'll put this in my calculator and see what we get. 26 lots of 3 plus 5 plus 9 plus 3 plus 5. And that's going to be 450 for that one. Yeah. This is a random example, but I hope that makes sense because that could come up. Yeah. But yeah, cool. And what else do I have? Yeah, that's pretty much it. Set notation as well, actually, that can come up too. So this one here, I'll just show you. Set notation, I know trips up a lot of us, but yeah, this one here for part B says find the set of values of k. Now set notation is easy. Let's just say this was your answer here. K is greater than 8 or k is less than 0. All you need to do is just put squiggly brackets. That's all they care about, right? And that colon there just means such that, right? Such that. So for example, k is greater than 8 or k is less than 0. All you would say is, well, squiggly k, squiggly bracket just to represent a set, and then k such that k is greater than 8, right? And remember from our unit intersection, we know that or has this symbol here. So we could just say k such that k is greater than 8, or k such that k is less than 0. That's how you write in set notation. I've got another example here. This was another example that I did in another question. T is less than 5 over 3, or t is greater than 13 over 3. So what I would recommend is uh doing the inequality first and then writing the set notation. So remember what we said here, or just means u, and then we've got the squiggly brackets here, t such that t is less than 5 over 3, t such that t is greater than 13 over 3. And to be fair, this might be confusing because you need the context of the question. So I'm going to wrap that out, right? But yeah, that's pretty much it. That's pretty much it for me. How are we feeling, guys? You guys feeling confident for tomorrow? Yeah. Okay. Cool. Let me just see the chat. I really need to sort out this lag with the messages. But yeah, that's pretty much it from me. Hopefully you found this helpful. And yeah, I just want to wish you guys the best of luck for tomorrow. Right? You guys are gonna do really, really well. Let me just see where am I further junior. These are the questions here. But yeah, you guys are gonna do really, really well. Just make sure you sleep early. What I'm gonna do is I'm gonna I'm gonna do the timestamps for this so you guys can watch this. I'm gonna do that before I sleep, but make sure you guys get a good sleep. And yeah, again, what can I recommend? Yeah, also as well, guys, just to quickly look at your specification, right? Just do a quick rundown of your spec, guys, please. I'm begging you. So what I did before the exam, when I did my A levels, just make sure you can go through all of these bullet points and say, I know, I understand every single thing here. So remember, let me just write limit as a sum, by the way. Sum. Let me write limit as a sum. I'm looking for something. Sum. Ah, but remember, integration as a limit of a sum. I did it on my TikTok the other day. But yeah, just make sure that you know that. I'm just trying to see if I can find it. Is it anywhere here? I'm looking, guys. I'm looking. Can I find it? I don't know if I can find it. I think it's 8.3, no? Found it? Can't find it. Yeah, found it. Brilliant. This right here. Can you see? I did a TikTok on this the other day. And yeah, it can come up. Don't let it trip you up. Another thing as well, integral of ln x is required. The way you integrate that is by doing by parts. 1 times ln x, do by parts. Just watch a video. I may do a TikTok on it as well. But yeah, that's pretty much it. And yeah, this is the specification for AQA. Look at that, and see how you get on. But yeah, guys, best of luck for tomorrow. Let me know how it goes. And yeah, just sleep early. And also as well, you can just watch my TikToks as well. Lots of different questions here just to get you prepared. But yeah, make sure you sleep early, guys. And yeah, you guys are gonna do really, really well. Make sure you let me know how it goes. Again, before I sleep, I'm gonna do the timestamps for you guys. But guys, it's been a pleasure. Good luck again. I'm gonna end the live now. Hopefully, maybe I can find an outro or stuff like that. But anyways, good luck. Let me know how it goes. And yeah, make sure you smash it tomorrow. Take care.